bit late. Our next speaker will be Steve Welburn from the Centre for Digital Music here at Queen Mary. We'll be talking about sustainable management of digital music research data. Steve.
Hi there. As Mark says, I'm going to talk about sustainable management of digital music research data, which isn't the snappiest of titles for a project, but it was a project on managing data within the Centre for Digital Music. I'm going to talk a bit about the project itself, give an overview of data management, talk a little bit about data management systems. So the project itself was a 6-month project from JISC, funded up till it was the end of May when it finished. There were 2 RAs working on it here in the Centre for Digital Music, and the 2 main goals were producing a data management policy for the research group, saying how the group intends to manage its research data, and produce a pilot data management system which would actually allow researchers within the group to manage their research data. Some of the motivation for this is the EPSRC, saying that they're going to expect people to be managing their research data properly and informing them how they're going to be managing their research data. So they have a set of principles for research data management, which include things like making your data available after you finish EPSRC funded work. Any long-term value, data with long-term value should remain accessible to people. And when they say remain accessible, their official line with that is that it should remain accessible for 10 years after the last time someone wanted to use it. This is a long time they're talking about. And that there should be metadata there, data about the data, which actually tells people what the data is, what it's useful for, and actually, who would want to reuse the data. They also ask for data management policies and plans, for you to actually tell them what you're going to do and how you're going to achieve it. And that you should actually adhere to those plans after you've created them. They're not just things you put on the bid for the grant. Published results, they should always include information on how to get the supporting data. This is what they're asking for. This isn't something you often see on a paper, unless it's a standard data set that's being used. If you've got a graph, if you ask someone where's the data behind that graph, you won't get that from most people at the moment. And also, the good bit of it for researchers is that all users of their research data should acknowledge the sources of their data. So if you publish your data and people use your data, you should expect to get cited for the fact that you've had your data used. This then leads into actually a benefit for the researchers rather than just being more work. So we did some work on policies and plans, policies generally being institutional level or research group level, higher level policies saying what you think you're going to be doing, what sort of infrastructure you're going to supply so that people can actually achieve things. And then there's the day-to-day management, the data management plans. The Digital Curation Centre have a DMP Online product, which the whole purpose of that is to allow you to create a plan to include with the grant proposal, which will actually go through and tick off all the questions the Research Council is asking you. So you can go through and go, yes, we have answered all the points they want us to fill in, and so that tool will actually help you create those. But the main thing I'm going to talk about is just generally about data management. Basically, there are 2 things you're bothered about. There's managing your data while you're doing your research, and there's what happens when you've finished. So during your research, you're changing your data quite regularly. It may be shared with collaborators, but you're not publishing it out to the public. And your main worry with your data is what happens if things go wrong. So, if your hard disk breaks, if you lose your USB stick, if you drop your laptop, if you overwrite your data by running buggy code on it, then what happens to your data then? How do you get back to where you were after you did that? And basically it's have backups. It's fairly standard. Of those 4 things at the top, the only one I haven't managed is breaking a laptop so far. So, if you're going to do a backup, put it on a USB stick, pretty common, then you can just carry it away and it's going to be safe somewhere until you lose the USB stick. Put it on the cloud, either send it yourself through Gmail, put it in Dropbox. Is that really a secure way to store your research data? Is it appropriate to put it on a public system somewhere where the admins could be looking at it and you don't know? Is it going to be available when you need it, that data? Who knows? Okay, put it on local storage in your research group, the box under someone else's desk. Is that an appropriate place? What happens if the building burns? You lose your computer, you lose the backup computer as well. University of Southampton Computer Sciences was 2005. Their building burnt. And if that was what you're relying on, is that any good? Probably the safest thing at the moment is an institutional network. So it's sort of, we have a drive we're in the electronic engineering building. Computer science have network drives. That's sort of distant enough that it's not a problem for us. But do they back up those drives? You put it on the network, you've got to go and check. You've got to figure these things out. If you want it to be backed up, check if it is backed up, ask them. Second approach to it, it's not just that the hardware breaks, people break as well. So you might be ill, you might have a couple of months away from your data, and you then get back to it. Is your data any use? Can you remember what it was? So you're going to have to, the thing to do is to document your data. It makes it easier to find the data when you need it. Makes you remember what the data's for, how it was created. And from a research perspective, it also helps you write up the research. It helps you make your research reproducible. If you're documenting your data, you've got to create some metadata about it, tell people what the data means, what are the columns in that spreadsheet of data you've got, that .mat file you created, what's in it, how was it created, which versions of software did you use, if you're using SoundSoftware, if you've got one of those tags on something saying this is a single version of data. Also, yeah, which source data was you used? Was it the Xanthakis data set? Some recommendations. If you're going to capture information about your data, do it as soon as you can. It's more likely to be correct. It's more likely to be complete. You're not going to forget some of it. Use meaningful file names and folder names. Again, it's a fairly standard thing, but you can identify things like what the source data was, what version of the code was. You can put those sort of things just in the file names. That's enough to let you know a fair amount about the data. README files, really useful things, just a little text file which has something which says what you were doing, what parameters you might have been using. If you include it with your code and your data, maybe you'll put it in version control as well. So whenever you go back to a version, you get the things that describe what your data was at that point. Again, things that were mentioned earlier, if you're doing live runs of data, put it in a script. That script then actually documents it and says, these were the parameters we used to produce this data set. If you need to go back and produce version 6 of your experiment, you have both the parameters and the code there, and you can rerun the whole thing. Something that often gets forgotten is things like default parameters on code. So you have your system there, you have the 3 parameters you've passed into the program. What about the other ones that you haven't entered any values for? If the version of that program you're using changes, are those parameters going to keep the same values? Do you know? After your research, data doesn't change much. It changes through doing some new research, some follow-up research on it, and maybe there's some correcting errors. However, going back to what was just being said by Bob, if you have a standard data set with standard errors in it, then that is one version of the data set, and you can compare things across research on that data set. If you have lots of different versions of the data set, each with a tiny change to it, how do you compare things across research papers without actually having to rerun all the experiments again? So, generally, it's recommended to keep the number of versions of things down. You do whole releases of data. So, you have 2 basic levels of data management after you've finished your research, which are archiving the data or publishing the data. So archiving, pretty much backing up, but for a longer term. So now documenting the data is important because you know it's going to be a while before anyone looks at it again. Publishing the data gives other people access to it. So could be on a personal website, but that might go if the computer science people decide you left 2 years ago and we're just going to delete that. So best thing is putting it on a repository somewhere. It could be a thematic one for a specific type of science. It could be an institutional repository. You could put it in both, an institutional one and a thematic one. If you put metadata in there, people will be able to find your data. If you're publishing data, you'll need to put a license on it. even if you can't publish data, you can still publish metadata that says, we use the following set of CDs in our research. That looks a bit repetitive. So, repositories, basically data management systems, they store data and metadata and allow people to find the data. We chose DSpace for our project, basically because it was a short pilot project. It provides a turnkey system you can install, so we could actually install it. It's got a large user base, so there's plenty of people out there who already know about it and actually accept that it's a decent system. And it supports standard protocols for transferring data between repositories. So actually, if we decide we want to use a different one, we can export the data and it can be used somewhere else. General recommendation for data publishing is published under CC0, which is basically waiving all rights to the data and just putting it into the public domain. However, scientific norms and the EPSRC still say that you should be cited for that. People publishing scientific reports on it should be referencing your work as well as for their data. So we just have basic metadata on our repository, titles, authors, dates, a preferred citation for the data. If you want to enter additional data, you can enter free text in there. Of course, you can also enter additional data as files in your data set. So with the repository as it is now, it means that the data sets that we've already got entered on there, if you go into Google Scholar and search for sort of C4DM RDR, it'll actually come up with all the data sets on our research data repository, listing people with the dates for the data, the titles of the data sets, and the authors of those data sets. So yeah, I mean, interest in data management is increasing, especially from the funding bodies. People should expect that it will become a requirement to have data management plans in place for their research. You should look after your data. It is probably something you've invested a lot of time in, and that really it's quite fragile. If you publish data, you may get citations, which is always a good thing. The only way people will find it, though, is if you actually document it. It's early days for research data management. Most of the tools out there are a bit sort of shaky around the edges, and that training in all of this is going to be becoming important. And on that basis, we have a follow-on project from this to talk about data management training for sound research. Thank you.
Thanks, that's very interesting. I'm just wondering, I see how this works very nicely in the EPSRC policies and stuff work very nicely with data where you're taking, say, CDs and doing some analysis on them. But I'm wondering about traceability in these repositories for where perhaps you've obtained an ethical approval and then human participant data, let's say a gesture capture system. And then, I mean, how do you, if someone decides to withdraw their permission for the long-term use of that data later, do these systems support your ability to go in and get rid of all that data?
Well, the usual thing that they support is what they call tombstoning, which is basically you take the data set, you remove the data, and you have an item there that says this data was removed on the following date for the following reason. So, yeah, I mean, there's a level at which it assumes that it's all right to have it there within sort of the boundaries of what you know at the time you publish the data. But yeah, it's generally regarded as reasonable that you can withdraw the data if issues arise.
One more question.
So I'm not quite sure it's a question, but it might be more of a comment. So I'm involved in this a little bit in my university. My take on data management when the DSRC make it mandatory is that researchers will do it because they have to do it, but they won't really do it because they think they want to share anybody else's data or because anybody else's data is really useful for them, because most of the time it isn't. It will just be somewhere to stick your data. In all the work you've done, is that a reasonable position to take? Because I've kind of been taking it on committee, so I'd really welcome your view.
I think it plausibly depends on the field.
I think it probably does.
I think a lot of the people in this room probably use other people's data as the starting point for a lot of their work. It's fairly common in the audio sort of research area, whether it is saying we use the following CDs, or whether it is actually something like the Sanitakis data set. There's a lot of data that's out there that people do use, and there's a lot of people creating data, and it's not necessarily getting out there as much as people would like it to.
Right. So it's I guess it's a lot more concrete in that domain, whereas in biology, so what we want it for, and what most people want it for, would be to model. And if it hasn't been collected with the idea of modelling in mind, then it probably isn't going to have. It's probably not going to contain the right information.
Yeah, I mean, but I think
is most scientific data. I mean, the big collectors of scientific data are the biologists and the medics. And so in that area, I think there's a chance we're missing the really key points that most data is actually.
But I think some of it also comes down to the issues people are saying about coding and things like that. It's training and it's good habits and good practice and things like that. And it's the things which actually, at the moment, seem like slightly odd ways of doing things, but which could mean that, you know, the EPSR policies come into full force in 2015. So it's sort of, it is looking ahead. So it's sort of, that is the stage at which you're actually talking about having all of this available. And that is a whole other set of PhD students away. So it's sort of, there's the chance to actually get these things embedded in the early career part of things and actually get these as ways that people think of working. So you were saying about having the models there, and actually if that's what you want, then maybe it's the time to start thinking is actually getting people looking towards that.
Well, I want them to collect the data in a different way. Actually. There's another issue, which is the amount of data. I'm not sure if they've really considered the actual amount.
I'm aware that there are a number of other questions up here, but what I suggest is that Steve will be around coffee to answer any more questions. But anyway, so let's thank all the speakers from this afternoon's session.